This is screencast number 3 for Unit 4, Lesson 1, and I am on page 178. How is velocity described? Well, speed, remember, describes how fast an object travels in a given period of time. Another way to describe the motion of an object is its velocity. The velocity of an object is its speed combined with the direction of motion. Okay, so velocity is more than just speed. Velocity is speed and direction. Now, sometimes you'll see the terms speed and velocity used interchangeably. If we're really picky, though, this is actually not correct. Okay? Objects moving at the same speed can have different velocities. For instance, a car traveling west at 20 kilometers per hour has the same speed as a car traveling east at 20 kilometers per hour. But the two velocities are different because the direction is different. So if the direction part of their velocity is different, the velocities aren't the same, even if the numeric value is both 20. Okay, so velocity is speed with direction. I'm now on page 179. A vector quantity is a physical quantity that has both size and direction. Okay, so it's those things that we measure that direction matters when we talk about them. Okay, for example, velocity is a vector quantity because direction matters when we talk about velocity. Speed is not a vector quantity because speed didn't matter when we talked about how fast an object moved. We didn't specify in what direction. So a vector quantity. Velocity is a vector quantity, but speed is not a vector quantity. Okay? Acceleration, which we're going to talk about pretty soon, is another kind of vector quantity that you'll learn about. Vector quantities can be shown on diagrams with arrows. Generally, the length of the arrow represents the size or the magnitude of the quantity. So like a big arrow would be a large velocity, a small arrow would be a small velocity, etc. And then the direction that you point the arrow is going to indicate the direction for that quantity. So if you take an arrow and you point it east, then you're telling me that an object has a certain velocity east. Or if you point it up, whatever. But the arrow indicates the direction, and how big the arrow is indicates the size or the magnitude of the number. All right, now I'm looking at average velocity is displacement over time. Well, displacement, remember, is not the same as distance. Distance is just how far did you travel, but displacement was how far are you from where you started, and those two things can be very different. For instance, if you run one lap on the track, you have run 400 meters, that's your distance that you ran, but you're back where you started, so your displacement is nothing. Okay, so if we're really, really picky, velocity is actually displacement over time. Okay, but usually we're just going to calculate it numerically the same way we calculate speed. It's just we're going to specify a direction. Okay, average velocity is calculated as the total displacement over the total time elapsed. We talked about average speed being total distance divided by total time, so they're very, very similar. Okay, recall that displacement is the change in position of an object measured as the straight line distance between an object's starting point and its ending point. A bus that travels 20 kilometers north and 30 kilometers south has a total displacement of only 10 kilometers south. To use that displacement to determine the average velocity, the total time elapsed must be known. Okay, so you can see that I can wind up with something very different if I'm talking about displacement versus distance. Okay. All right, we're going to do the graph on page 179. So take a look at that. And notice, first we're going to do number 13 on 178. So let's look at that first. It says, identify the velocities of the fastest ship and the slowest ship shown below. The fastest, I'm going to look for the biggest arrow. Okay, and the fastest one that I find is the boat that is traveling south at 8 kilometers per hour. So since it's asking me for velocity, I'm going to put 8 kilometers per hour south because I have to give both a speed and direction for it to be velocity. The boat that is traveling the slowest appears to be the one that is going east across Galveston Bay at 1 kilometer per hour. So I would put 1 kilometer per hour east. Okay. On number 15, a ship is traveling south, assuming that the ship had a constant velocity during each segment of the cruise. Make a distance versus time graph using these values for total distance traveled. And then it says to use your graph to determine the velocity of the ship during the 1 hour period from 2 to 3 hours. Okay, so let's do the graph before we attempt to answer the questions. Okay, before we take a look at the graph on page 129, let's go over what we talked about on both of these pages. I went back and I underlined the definition for velocity. The velocity of an object is its speed combined with the direction of motion. Under velocity is speed and direction, I underlined where it says you sometimes see the terms speed and velocity used interchangeably. I also underlined where it said objects moving at the same speed can have different velocities. And then on page 179, a vector quantity is a physical quantity that has both size and direction. So I underlined that. And I also, later down in the paragraph, I found the sentence that said vector quantities can be shown on diagrams by arrows. Okay, remember that the length of the arrow represents the magnitude or the size of the number, and the direction that the arrow points is the direction of that quantity, whether it's a force or an acceleration or velocity or what have you. Okay, and then average velocity is displacement over time. I underlined where it said average velocity is calculated as the total displacement over the total time elapsed. And then I added some more notes up there over where it says which way. I put examples of vector quantities, meaning examples of things that have to have a direction in order for them to be meaningful. Velocity is a vector quantity, meaning it has both a size, a number, and a direction. Displacement is a vector quantity. It has both a number and a direction. Acceleration is also a vector quantity. It has both a size or number and a direction. Force and weight. Weight's actually a specific type of force. Momentum is a vector quantity. Okay, we won't talk about what momentum is here, but it's another type of vector quantity. Vector quantities have to have a direction to be meaningful. So they have both size and direction. Okay? Speed is not a vector quantity because we don't specify a direction with speed. Okay? All right, let's look down at the graph and answer or do 15 and 16. Okay. Number 15 asks you to create a graph, which I have done, and you should probably follow along and do the same thing. Remember that time is usually something that goes on the x-axis, so I put time in hours on the x-axis. Distance in kilometer is on the y-axis. Number 16 says analyze. Use your graph to determine the velocity of the ship during the 1 hour period from 2 hours to 3 hours. Okay. So let me show you what section of the graph we're talking about. All right, we're talking about just the part of the graph that I have shaded in green. Okay, here's where we are at 2 hours. Here's where we are at 3 hours. Now, if you will notice, from 2 to 3 hours occurs along this part of the graph, and that is a nice straight line, so that ship is going a constant velocity from 2 hours from 1 hour all the way up to 4 hours. So really all we need to do is find the slope of that line to determine how fast the ship is traveling, its velocity, during the hour from 2 to 3. All right, so we're going to do that real quickly. Okay, notice that what I've done is I've put the equation here for average velocity. It's going to be calculated the same way as we do speed. So the change in distance divided by the change in time. And I'm just looking at that one little section. So we ended at 8 kilometers at the end of that 1 hour section. And we started at 5. So 8 minus 5 is our change in distance. And 3 minus 2 is our change in time. So 3 kilometers divided by 1 hour, and that is 3 kilometers per hour. And actually, the ship is going 3 kilometers per hour for that whole section, from time equals 1 hour all the way up to time equals 4 hours.